Please welcome Vesko.
All right. Well, it's great to be here. Thank you for having me, and thank you for staying. Now, I go by Vesko. I do lead the Advanced Development Center at VMware, and that means my day job is to, work with amazing people, get disruptive tech, and try to de-risk it so that it goes into the business lines. But now, my good friends and colleagues at ISTA, organizational committee, they came and said, all right, you do interesting stuff, right? Can you do a keynote? And that was my reaction. And pretty much the hair is kind of like that. If you're as old as I am in this industry, you know this guy, Doc Emmett Brown, crazy stuff, right? But they're like, OK, what do I talk about? And they're like, don't worry, this is the closing keynote. This is just between, you're going to be the last thing between a day of interesting stuff and the cocktail. So no one's going to pay attention. Don't worry about it. Right. But still, after 2 years of staying off stage, I said, all right, what can we do? And thinking of Doc Emmett Brown, I was thinking, hey, it's kind of like a Back to the Future moment for me, because I was on this stage in 2016. And in 2016, I had a talk about polyglot developers. Right. So back then, we talked about different languages, ways to what to learn, what to handle. We spent most of the time talking about two important topics. One was ransomware. The other one was blockchain, smart contracts. And mind you, that was 2016, so for better or worse, I think it's mostly worse. The predictions came true. I guess both of these topics are very relevant right now. So in preparing this talk, I wanted to think about what is going to be useful for you. And maybe we can get back here in a couple of years and see whether this panned out, right? So if you pay no attention whatsoever from now on until the end of the talk, which is fine, remember two things. I want to take you on a brief journey through two topics. One of them is going to be AI and machine learning. And my claim there is going to be that actually some real progress is made, and you should care. And we're going to talk about perhaps some areas you should care about that may not be the most obvious ones when we say AI and ML. The second one is going to be good old systems engineering. I'm talking about languages, compilers, architectures. And in particular, I'm going to talk about something we call WASM. A lot of you probably know it, but I'm going to touch base on WebAssembly. So with that, let's dive in. Obligatory disclaimer. This is a keynote. I love doing talks. I love doing hard ones with data and performance stats and all of that. This is not it. These are opinions. They're my opinions. I tend to be wrong about stuff, so keep that in mind. Still, I claim AI/ML is eating the world. And if this is familiar to you, it's because Mark Anderson from the VC firm, Anderson Horowitz, said it circa 2011. His quote was, "Software is eating the world," and the claim was that software is getting into so many of the domains, be it healthcare, autonomous driving, or something like that, that everything is going to be disrupted and changed by software that we are building. OK. I'm playing a twist on that and claiming that AI/ML is eating the world. So to tell you the truth, I was usually reacting like this guy would on the picture, eye rolling. The reason why I would eye roll like that is because, well, we have this internal innovation conference. I used to be chair of it a couple of years in a row. And, circa 2017, AI and ML were at the height of the hype curve. If you've never seen one of these before, that's Gartner's hype curve. Until you get to the plateau of productivity where we all want to be, you have to go through all of that. And at that time, it was up there. Every second paper, that's sort of between academic and industry papers, was about machine learning. A lot of it was statistics, hidden like machine learning, but doesn't matter. So I was a little bit skeptical. Let's try to use this everywhere. But then, in preparing for this talk, I said, OK, how do I demonstrate the immediate value of machine learning in our lives to grab your attention? And you know what? The previous slide, that was a stock photo. I just found it on the internet. I hate using stock photos. Don't do that in your presentations. You could even see the water markings. And I was like, OK, I'll never use that. Can I do something better? And I could. I actually went in, ran the Stable Diffusion model. Stable Diffusion is, we're going to talk a little about OpenAI, but it's one of the OpenAI-based models that can draw based on a prompt. So I gave it a prompt, watercolor, Sophia, Impressionist, and best of a subreddit. It tends to work good for the model because of the way it has been trained with other images. And it produced this. And I think it's pretty nice. This picture is going to be free of copyright, free of any licenses. I could use it in my presentation instead of an ugly stock photo, and it's unique. It was generated for me. And now, I started playing with it, and it's doing pretty good. And by the way, I tried to do a small tweak. I added to the prompt watercolor Sophia pavement. Impressionist and best of watercolor, and if you live in the city, you might get the joke. The pavement that it produces is pretty good, I would say, but the machine prompted me that, look, this is taking longer than expected. So if normally it would take 30 seconds, this one took 3 minutes. And I was like, yes, I know it's taking longer than expected. So another one of pavement jokes. But all joking aside, it's actually doing pretty well. So this is a conference in Sofia that the computer imagined. The next one is Sofia City Sunrise. The third one is the Sofia City Autumn in Vitosha. And I think they're pretty good. Maybe they're not as good as some other things, but we're getting there, and we're getting there very fast. So let's talk a little bit about DALL-E. DALL-E, which I used for the previous 3 pictures instead of Stable Diffusion, is another. Actually, this is how it started. You've probably seen this all over social media. Now, also regular media is piggybacking on this. It was presented as a paper. Originally, I think it was even a blog post at the beginning of 2021 by Adam Kuciak and his team. So you could generate images from text captions. It's a 12 billion parameter version of GPT-3. GPT-3 is the OpenAI's model. You have a big data set of text-image pairs, and it gives you the power to combine unrelated concepts, like this illustration that they use in the paper of an avocado chair. And this is the computer's interpretation of what an avocado chair is, because usually avocados are not related to chairs, but at the end of the day, I think it's doing a pretty good job. Again, opinions here. But still, I mean, what is DALL-E? How magical it is? Well, it's actually very evolutionary, I would say, in terms of machine learning techniques. I mean, if you know what an autoencoder is, what a variational autoencoder is, and now they did present the technique of the vector quantized variational autoencoder, and let me tell you, that's a mouthful. It's a pretty interesting paper if you're into that kind of things. Actually, as part of this paper, you realize that every good scientific paper, you should be able to replicate the results. And to replicate the results, the problem is you need 1,000 of NVIDIA's Tesla GPUs, which are about, I don't know, these days they're about $3,000 to $4,000 each. I don't want to imagine what it was back then, but you need a pretty big cluster. So it's cool. And it's getting more and more accessible. And to two things that you can learn from that. If you have a lot of data, and we can go into how we generate that data, because could we use AI and ML techniques to do that? Yeah, sure, we can. GANs. If we have a large enough model with a lot of parameters, we can have some impressive results. Caveat is, training that model is going to be hard. Now, about machine learning. I'm not going to give a talk going into the specific of what an autoencoder is, how to use it, how to apply it. But I wanted you to recognize the fact that the machine learning algorithms hidden under the hype are nothing but good computer science and applied math. And I personally trust computer science and math. Of course, there is a lot of computational power involved. And we'll get to that in a minute. Now, with that, you can have some amazing results. And not only in image making, you can have song composers that actually can, given a prompt of music, can continue the song. You can have solutions for, I love the previous talk about enabling people who cannot see and bettering their lives. You can have self-driving cars and all the other things that you regularly hear when you associate with machine learning. But now, what does that mean to me as a computer scientist? Well, I love this quote. It's by one of the former VPs of Airbnb, who was saying that every time you interact with our service, be it the website, be it the mobile app or something like that, you interact with machine learning. And I bet you that the top apps that you use on a day-to-day basis, no matter where you're based, here or elsewhere in the world, are going to be using machine learning, or in some shape or form interacting with machine learning models. So what does that mean? Well, that means that you need some, I would call it a working knowledge of the machine learning concepts. Now, this is an illustrative workflow. Don't worry about it. But do you know if a model that is being deployed by your data scientist group is CPU or memory intensive? Does it need specialized hardware? What is the cost of a training run? Do you do it in the cloud? How often do you have to rerun it? Some training runs of some commercial applications cost hundreds of thousands of dollars to train the model. But then do you need to retrain it? What do you do? Does it make sense to invest in your own infrastructure if you're going to be doing that fairly often? And even from a product marketing standpoint, from a product ownership and business standpoint, how do you work with machine learning when you have it as part of your apps? Do you create a horizontal product, and so you make one model and you apply it in different scenarios, sort of like OpenAI with GPT-3? Or do you tailor the model because you need to for each individual customers? And what that means, if you choose the second route, is that you perhaps need to structure your business in a different manner. Maybe now you're a services business where you have sub-teams tailor, customizing each machine learning model for a particular customer, and then dealing with a different level of margins and way of doing business and fixing things. And I don't know if any of you are running or working in machine learning startups, but perhaps this sounds familiar to some of you. So what I'm getting at is that machine learning algorithms that are most commonly displayed are just a tiny fraction of the ecosystem that we should care about as professionals. We need to care about configuration. We need to care about feature extraction. We need to care about how data is being collected. We need to care about the infrastructure that runs this thing. We need to care about boring things like monitoring and process management and all the rest of the usual software engineering business. But are you going to be able to do all of that we do without at least having some concept understanding of what it is? And this conference started as a quality engineering conference back in the day. How do we do quality engineering on one of those? Do you understand the attack models? I mean, I love this because it's easy to understand. You've probably seen it. You get a picture of a dog, and you add some very well-constructed noise to that picture, in which the human eye cannot discern it, but of course, the computer can. So it gets correctly classified as an ostrich, which is, of course, hilarious, until you realize that you can actually do it with real objects, and perhaps, as this experiment showed, you can have specially crafted stickers, stick them on a stop sign, and then the self-driving car interprets that sign as, let's drive with 120 kilometers per hour. And then it stops being funny very quickly. So how do we curate our data? How do we work with it? How do we deal with biases in the models? There are studies that show that your output is going to be as quality as your input for your training data. So you are going to run into problems if your training sets have a bias in them. How do we do explainability? And as we start to interact with machine learning applications more and more, for example, even when we don't realize it, we go to the bank, we ask for a credit, and the credit inspector actually asks an app what your credit score should be or where your trustiness. Or maybe you go to the doctor wanting to read an X-ray, and the practitioner relies on another app that actually looks at and tries to help them interpret the X-ray or the scan. Now, it's going to give you some result with some probability, but that practitioner right now is going to have a very hard time explaining why that particular result came into being. So explainability, tomorrow, it should get the user of machine learning applications knowing exactly why the machine decided a certain outcome instead of another one. All right. And you might say, OK, honestly, I don't care about that. That's for QE, for DevOps folks to worry about infra. It's for the data science folks to figure out with the models. I'm a software engineer. I write code. I don't care. Well, have you seen Copilot? If you haven't, do so. But in this particular tweet, someone was complaining, all right, look, I actually wrote a function, and you write the function name, and you rely on Copilot, if you haven't used it, to give you suggestions. And in this case, the suggestion gave you, OK, you should throw an error because you don't want to invert the binary tree. That's dumb. And obviously, that's not the function you were looking for and the help you were looking for. But again, that's the data sets. All right. So this is going to be more and more pervasive. Pay attention to it. But learn at least enough about machine learning to have an idea what it's doing behind your back. All right. Shifting gears. Enough about machine learning. I hope I turned at least some of you from skeptics to curious people. Now, I look around the audience right now, and I see a lot of you using devices while I'm speaking. Now, some of these are ARM-based devices, right? Some are, I see laptops, so Intel probably based, but I see some MacBooks as well, so M1 or M2 chips, I don't know what's inside. I probably don't see any RISC-V devices, but trust me, soon there's going to be at least, if not here, then around the lights or in the control pods over there. So lots of architectures. Let me tell you about WebAssembly. Now, WebAssembly is a very cool open standard that defines a new binary format. And that binary format is started with the browser, as many things do these days. It's supported, in fact, by all major browsers. You could run an executable program there. It's very cool. I like it even more because, I mean, riffing on the theme of polyglot development, you could write in Rust, you can do Golang, C, And then you get into this portable bytecode format. But the cool part is it executes across architectures. Now, I'm a server-side person, so these days you can do a lot of that magic in the browser. Google Earth, Figma, Unity all have WebAssembly in them, but Solomon Hykes, one of the initial creators of Docker, was saying, all right, if in 2008 we had WebAssembly and the system interface, we would not need to use Docker and containers. We'll probably not need to create it. Because it gives you a lot of the power, WebAssembly has a very interesting sandbox. It's very efficient. It's polyglot, so you could fulfill some of the promises of what containers gave us as engineers. It's open, so it's a little bit in a better position than, for example, what Java was when it was invented, backed by only one company. WebAssembly is backed by the Bytecode Alliance. And most of all, it's portable. Because, look, as software engineers, we always solve. There is a lot of boring stuff that we need to do until we get to production. I mean, we create the technology, but then we need to build it. And do we keep different branches for the different architectures normally? Do we need to perhaps just have different make files and build different deliverables and then store them in different repositories? And then, OK, if we need to patch one, do we patch the other one? I mean, I'm talking about that whole sequence of, I would say, important but boring work that we do right now, and if we have even more architectures, we'll have to do even more of that. So it's exponential, actually, expansion. And this is a cool piece of tech that promises maybe what Java promised originally in terms of not only cross-operating systems, but in this case, cross-architecture. So with that, to recap, and as I promised, I'm not going to go over because I'm the only thing that's between you and the cocktail. I didn't know even that it had some music, but this is Stable Diffusion, one of the AI models I showed you, running on the new virtual reality platform that was just showcased by Meta this week. You can see that it actually gets generated, computer generated. You need a lot of firepower, you need a lot of computational power to do it, but you can do it on the go. So imagine being in a virtual reality landscape that gets auto-generated for you by the computer, just by prompts. No designers, except for the ones that give you the prompts. I find it amazing. It has its quirks, it's early, but I find it pretty good. And enough of that. Before we get dizzy, because that's another area, but I'm not going to go into it, virtual reality. I love this quote by Bill Gates. It's an old quote from '96 that we tend to overestimate what's going to happen in the next 2 years, but severely underestimate what's going to happen in the next 10. So how about we do this? How about we do this? In 6 years, we all come back here and see how many of these things panned out. Thank you. By the way, if you want to geek out about some of these topics, find me afterwards in the speaker's corner. Are there any questions?
OK. Thank you, Vesko.
Awesome.